This is section 10.2, quadratics and translations of functions. Quadratic function is defined by f of x equals ax squared plus bx plus c. We're used to seeing that. Most of us know that it is a parabola in shape. The lowest or highest point is called the vertex. That would be down here. And the line that goes through the vertex is the axis of symmetry. That's not written on there, but that you might see that at some point. The highest point, if this is going this way, and we have a high point, that's called the maximum. The lowest point would be called the minimum. If we want to find the max or the min, we can totally do that using our calculator by putting the quadratic in y1 and finding the max or the min, and we'll be doing that in this section. Sometimes it's just as easy or even easier to use the vertex formula. Remembering that these letters A, B, and C are in the generic form there, the formula for the vertex is negative b over 2a, comma, f of that, meaning you would plug whatever you get here back into the function. If the a is positive, in other words, if this a is positive, it's going to open upward like this. If that's negative there, it's going to open down. Now, to talk about translations, we need to talk about basic graphs because we could look at some other than x squared. So we've said that's what x squared looks like. Square root of x begins at 0, 0 and goes this way. At least the basic one does. The basic absolute value has its vertex at the origin and is a v going this way. And then x cubed is what we call a drain pipe. It goes up, curves, goes through the origin and up that way. So now that we kind of think about the basic graph, then we need to think about what certain things will do to the graph and move it. So the first one we want to look at is vertical shifts. When we have a function and we add or subtract a value outside the function, it's going to shift it either up or down. So if you add, you're going to shift up. You subtract, you shift down. So in other words, here's your basic one. That's x squared. X squared plus 4 takes that vertex, shifts it up 4 units, and puts it right there. Should be on that hash mark. X squared minus 5 takes the vertex and shifts it down this way. All right. Horizontal shifts. What's different here is that you are still subtracting or adding something, but you are doing it within the function. In other words, in parentheses for x squared or x cubed, inside the radical for square root of x, or inside the absolute value bars. It is not what I think should be intuitive. If we subtract, we move right. If we add, we move left. So you have to be careful with that. But here's a picture. Here's a square root of x. The square root of x plus 4, it's going to move left. So that vertex goes that way. Square root of x minus 2 goes to the right 2 units. Reflections. And really, I want you to focus on this one. If you, like we said at the beginning of the notes, if there is a minus in front of the x squared, it goes upside down, so it reflects over the x-axis. And the only other thing, if there is a number, a constant in front of the function, then what it does is make, if the number is bigger than 1, it makes it skinnier. If it is between 0 and 1, it makes it wider. In other words, here is x squared in the blue. Red is 3x squared. The green is half x squared or 0.5x squared. So it doesn't move the vertex at all. It makes the graph either skinnier or wider. And I think that will get you going. Let's look at the problems. All right, let's look at the first problem. Match the correct graph to the function without using your calculator. So we're going to use that idea of the translations. In this one, we have x squared minus 1. So remember, if we're adding or subtracting, we're going to move up or down. So that means we're going to go down 1. When we look at these pictures, this one went left, this went up, this went right, this one went down. Okay, here we're doing x plus 2 squared plus 1. So we've got something added inside the parentheses. That means we're going to go left 2. This one says we're going to go up 1. So we're looking for two things. Which one goes left? Well, this one does and this one does. These two do not. So this one went to the left but did not go up. This one went left and did go up. So it's C. This one is graph the parabola and give its vertex, axis, x-intercepts, and y-intercept. Now we're going to use our calculator on that. And so if you go to your calculator, you can simply go to y1 and put in x squared plus 16x plus 60. You should get this graph here. All right, choose the correct axis of the parabola. Well, we need to find its vertex in order to do that. And I did that here. I did second calc min. So let's do that. I'll do one with you so that you have that there. All right, let's see. So we've got x squared plus 16x plus 60. All right, so in having this picture, I need to see a little bit more over here because I know I'm going to find the x-intercepts. So I'm going to change my window and make the x-min negative 20 just to get a better view. All right, and to find the min, second calc I think I hit that twice. Let me do that again. Second calc min is number 3. Now you want to move your cursor so that you're to the left of that minimum point and hit enter. Then you want to move it to the right of that minimum point and hit enter. Then you hit enter a third and last time, and the minimum is -8, -4. So we had to put that in here. The vertex is, put that in. Choose the correct axis of the parabola. Once you know the minimum, remember that that line that goes through there is the axis of symmetry. And so it's always the x part of that parabola that you use. So x equals -8 is the axis. All right, the x-intercepts. So if you also go here and put in y2 is equal to 0, you can do second calc. Let's pull that up and do that one as well. Second calc number, oh wait, I didn't put my y2 to be 0. Oh, I already had it. Good. Okay, we'll go back. Second calc 5, and we'll hit enter 3 times. We went to this one right here. That's x equals -6. To get the other one, second calc 5, but before we hit enter, we want to move to get over close to that other one and hit enter 3 times, and we get -10. So those screenshots are there, but that's how I got those. X-intercepts are there. the y-intercept, well, when x is 0 is when you get your y-intercept. So if I look at this function and let that be 0 and that be 0, my y-intercept is 60. And then we're asked to choose the correct graph, and we've got that. Even though that looks a little different, if I changed the window in my calculator to match that window, so if I went here and did an x-min of, looks like, I don't know, we can leave that one. No, I can't tell what that is. Oh, the x-min is -15, and the x-max is 5, and y-min is maybe -7, and y-max is 64. Let's see what that looks like. Okay, so I think if we do that, we can definitely tell that it is B. So sometimes if you're asked to pick a graph, be sure you change the window. All right. So number 4 is exactly the same. I'm not going to do that one on the calculator, but I do have the screens here for you. When we put that one in, you would put in y1 equals -2x squared minus 32x minus 126. And it is going upside down, and we found the vertex by doing second calc max, because this is a high point, and we found the vertex to be -8, 2, so the axis is -8. X-intercepts, found those here, -7, -9. If I let x be 0, then -126 is my y-intercept, and then I find my graph by doing that. All right, another translation, we've got the square root of x plus 1 and then a -3. So that means inside, that's going to go left 1 and down 3. So here's your original. We're going to go to the left 1 and down 3. And so we're starting here now. All right. Negative square root of x minus 4 minus 1. So again, you could put that in the calculator and see it, but we kind of should be able to do that at this point without having to put it in our calculator. So get that to erase a little better. Oops. All right. So basic one looks like this. Inside it says it's going to go right 4, down 1, but we have a negative here. So this thing is going to flip. Imagine that it's just flipping over upside down, and so it's here. This is where the vertex starts and goes this way. So you can tell that it is right there. All right, number 7, let C of x be the cost to produce x widgets and R of x to be the revenue. For this exercise, graph both functions, find the minimum break-even, and find the max revenue and max profit. So this is a business application of what we're talking about. So if we take the revenue, which is -x squared plus x, and the cost, which is a straight line, 4x plus 3, I put them both in the calculator. So we have y1 equals -x squared plus 8x, and y2 equals 4x plus 3. So I got my parabola and I got my linear equation. So we are right here. You could change the windows and make sure, but I think you can tell which one it is. Find the minimum break-even quantity. Well, you break even when your revenue, how much you're making, is equal to your cost. So we need to find out where these two intersect. and that is at x equals 1. Okay, x equals 1. That's the minimum break even, because it looks like they break even up here as well, but minimum would be this lower one. Find the maximum revenue. Maximum revenue. Well, revenue was the parabola. Okay, so second calc max, and you get x is 3.99. That's the x value, but when you're finding the maximum revenue, that's your y value, so it would be 16. Find the maximum profit. Maximum profit is revenue minus cost. So negative x squared plus 8x minus the cost function. And that becomes this. 8x minus 4x is 4x. So here's your maximum profit cost. Put that in your calculator. So we put in y1 equals negative x squared plus 4x minus 3. Graph that and find the max, which is down here. You find that y is equal to 1. All right, we have another application problem. If an object is thrown upward with an initial velocity of 64 feet per second, then its height after t seconds is given by this equation. So here's our equation, and I'm going to change it into x because we're going to put it in the calculator. Y. Okay. Let's see. That is, I don't know why that was doing that. Here. Right, y1 equals 64x minus 32x squared. So definitely the x squared is negative, so we're going to get this shape of a parabola. We put that in, and it says find the maximum height. So we simply find the max of that parabola, second calc max, and the y value of that is 32. Says the number of seconds it takes the object to hit the ground. It hits the ground. When it's on the ground, the height is 0. So you find the x-intercepts. It's on the ground here, and it's on the ground here. Well, we don't need the 0. We're talking about the number of seconds to hit the ground. So it starts out on the ground, goes up, and then comes down. So that x value is 2. That x-intercept is 2. Right. A college is planning to construct a rectangular parking lot on land bordered on one side by a highway. They're going to use 520 feet of fencing to fence off the other 3 sides. What dimensions should it have if the enclosed area is to be a maximum? This is a really common problem. We did this in college algebra. So you've got enough fence to use 520 feet. We don't have to fence in along the highway. So if we make that side and that side be x, because they're the same, then we've used up 520. So 520 minus 2x, which we've used, that gives me this other side. Now, since we're looking for maximum area, we want to remember that the formula for area is length times width. So we're going to do this times this, and when we distribute, we get 520x minus 2x squared. If we do that in the calculator, we're going to put it in, and you may have to do a zoom 0 to get a picture and maybe adjust your window. When we find the max of that, the x part is 130, which is the width. The maximum area is up here. The length, we said, if you go back up to our picture, is 520 minus 2x. So 520 minus 2 times 130 is 260. So we were asked the width and the length. And so width was 130, length was 260. So that's how you would work that one. I think that's all that we're asked to do. So I think you should be fine on that. Let me know if you need any other help.